3.4 is called zeros of polynomials, and it's going to have a lot of different objectives, and we're going to take a look at question types we need to understand with this lesson. So the first objective is listing the possible rational zeros of a given polynomial. So one of the objectives we have to master in this lesson is listing the possible rational zeros for polynomials. Okay, so here's the first question that I have here that we're going to do together. I have this polynomial given, x to the fourth power minus 19x squared minus 2x minus 6, and we want to list the possible rational zeros. Again, these are not finding the actual zeros, these are finding the possible rational zeros. So in order to do these questions, we always look at the last number within the given polynomial. So the last number here is 6. So I'm going to take the 6, and I will find the factors of 6. I can divide 6 by 1, so plus and minus is factors of 6. I can divide 6 by 2 without a remainder, so plus and minus 2 is the factors of 6. I can divide 6 by 3, so plus and minus 3 is the factors of 6. And last thing I can do with 6 is I can divide it by 6 without a remainder, so plus and minus 6 is also factors of 6. So we always start with the very last number. Then we will need to move to the leading coefficient. So we have 1 times x to the fourth power here. So the leading coefficient is just 1. And the factors of 1 is just plus and minus 1. That's the only number which is going to divide the 1. Now I am ready to write down all the possible rational zeros, and I will show you how I am going to find you. I'm going to find them. So all possible rational zeros, here's how we're going to find them. So the top numbers that we write here, so let's change color. So we're going to do 1 divided by 1. So 1 divided by 1 is just 1. So one of the possible rational zeros is plus and minus 1. Then we're going to divide 2 by 1. So when I divide 2 by 1, 2 divided by 1 is just plus and minus 2. Next, I'm going to divide 3 by 1. So 3 divided by 1 is plus and minus 3. And finally, 6 divided by 1, what I need, which is plus and minus 6. So in this case, this polynomial x to the fourth minus 19x squared minus 2x minus 6, the possible rational zeros among will be one of these numbers. So this polynomial might be divisible by positive 1 or negative 1. It might be divisible by positive 2 or negative 2. It might be divisible by positive 3 or negative 3. It might be divisible by 6 or negative 6. For example, since 7 is not among this list, 7 is not going to work here. Since 10 is not a possible rational zero, 10 will never perform a synthetic division for this polynomial with a remainder of 0. So let's do another one to understand what we're doing here. So we're going to just the second question we're going to look at is the same idea, but we have a different question. Again, the question is list the possible rational zeros. So we're going to always start with the last number, which is 14. I'm going to take the last number, 14, and I will find the factors of 14. We can divide 14 by 1. I can divide 14 by 2. I can divide 14 by 7. And I can divide 14 by 14 without a remainder. So these are the numbers which are factors of 14. This time, the leading coefficient, which is the number in front of the biggest exponent, 4, is the other number that I need to find the factors. So you always find your leading term, the greatest exponent and number in front of it. For 4, I can divide the 4 by 1, I can divide the 4 by 2, and I can divide the 4 by 4. So there are 3 factors of 4. Now, I'm ready to create the list for possible rational zeros. So the first number we're going to stick is 1. 1 divided by 1 is just 1. Then 1 divided by 2 is 1/2. Next, 1 divided by 4 is plus and minus 1/4. So these three numbers generated because we divided 1 by all of these factors of 4. Next number in line waiting for me is 2. Now, 2 will be divided by these three bottom numbers. 2 divided by 1 is 2. 2 divided by 2 is 1, but 1 is already in the list, so we don't need to duplicate it. 2 divided by 4 is the same fraction as half, but it's already in the list, so we don't need to duplicate it. I'm ready to move to next number, 7. So we're going to divide the 7 by these three numbers at the bottom. 7 divided by 1 is 7. 7 divided by 2 is 7 over 2. And then 7 divided by 4 is 7 over 4. Next number is 14. 14 divided by 1 is 14. 14 divided by 2 is 7, but it's already in the list, so I don't need to repeat it. 14 divided by 4 is the same fraction as 7 over 2, so I don't need to duplicate it. So all of these numbers here, they are called the possible rational zeros for this certain polynomial function here. I have more examples to repeat this procedure. Another polynomial function, again, we want to find the possible rational zeros. So I don't really care about the sign of the last number because I'm getting the plus and minus version of it anyway. So I'm going to take the 6 and I'm going to find the factors of 6. I can divide 6 by 1. I can divide 6 by 2. I can divide 6 by 3. And finally, I can divide 6 by 6, which is 6. Next here, I have the negative 9 as the leading coefficient. And I don't even actually have to take the negative sign here because we don't really care. We're always getting the plus and minus version of it anyway. So I can divide the 9 by 1, 3, and I can also divide it by 9. Finally, I'm ready to create the list by looking at the combinations. So I'm going to start with 1. 1 divided by 1 is 1. 1 divided by 3 is 1/3. And now 1 divided by 9 is 1 over 9. Okay. Next. 2 divided by 1 is 2. 2 divided by 3 is 2/3. 2 divided by 9 is 2 over 9. Next number is 3. 3 divided by 1 is 3. 3 divided by 3 is 1. 1 is already here, so I don't need to repeat. 3 out of 9 is 1/3. It's already here. I don't need to repeat it. 6 divided by 1 is 6. 6 divided by 3 is 2, and it's already in the list. 6 out of 9 is the same fraction as 2/3. And these are the numbers that will be the possible rational zeros for this polynomial function. And now we have this question related to same objective. Which of the following is not a possible zero for f of x is equal to 6x cubed minus 7x squared plus 10? So I have this polynomial function is given, so I need to decide which one is not going to be a number, which one is not going to be a possible zero for this question. Just like the other problems, the last number is 10. So we're going to write the factors of 10. So we can divide it by 1, we can divide it by 2, we can divide it by 5, and we can divide it by 10. The leading coefficient is 6. So I can divide the 6 by 1, I can divide the 6 by 2, I can divide the 6 by 3, and I can divide the 6 by 6. So these are the factors of 6. Now I'm ready to create the list of the possible rational zeros for this function. And I'm going to see which one is not among the options. So we're going to start with 1. 1 divided by 1 is just 1. 1 divided by 2 is 1/2. 1 divided by 3 is 1/3. 1 divided by 6 is 1 over 6. Next, we have the 2. 2 divided by 1 is 2. 2 divided by 2 is 1. It's already here. 2 divided by 3 is 2/3. 2 divided by 6 is 1/3, and it's already here. Next is 5. 5 divided by 1 is 5. 5 divided by 2 is 5 over 2. 5 divided by 3 is 5 over 3. 5 over 6 is 5 over 6. Next number in line is 10. 10 divided by 1 is 10. 10 divided by 2 is 5, but it's already here. I don't need to write it again. 10 over 3 is 10 thirds. And then 10 out of 6 is the same fraction as 5 over 3, so I don't have to repeat it. Now, let's check now. 7 over 3, is this here? 7 over 3, I don't see it among the options. Let's see. I do see the 10. 10 is in the list, so 10 is possible. What about 3? 3 is not in the possibility, so 3 is not possible. 3 over 5, 3 over 5 is not a possible 0. 3 over 5 is also not possible here. It's not here. Maybe, I don't know, I took this question from Alex, but maybe they meant which one is a possible 0. Because here, if we only focus on the possible 0, this is the only possible 0, and everything else is not going to work. So while you're doing the Alex homework, you can understand the reasoning behind the question. If they keep marking me wrong, you can tell me, and I can delete this question from the home. Okay, now, finally, we're moving to a different objective for this lesson, and it's a very important objective. So this objective is, do not find only the possibilities, but now, can you actually find the zeros of a polynomial function? So objective 2 is finding all the zeros of a polynomial function. Polynomial function. And we're going to use the first objective, and we're going to use synthetic division. We're going to do everything we can to handle these questions. So x cubed minus 7x squared plus 13x minus 3. We're going to find all the zeros and write the answer in exact form. So first, I have to guess one of the zeros that will work for this question, and then I'm going to apply synthetic division. Well, how am I going to find which number actually works for this? So I'm going to find what is possible. So just like the other questions, the last number is 3. I can divide 3 by 1, and I can divide 3 by 3. And then the leading coefficient is, we have 1x cubed, so the leading coefficient is just 1, which makes the factors to be just plus and minus 1. Now, when I look at the combination of these two factors, 1 divided by 1 is just 1. 3 divided by 1 is just 3. So one of these numbers, either positive 1 or negative 1, positive 3 or negative 3, one of these numbers has to be a rational 0 for this question. But I don't know which one. So we're going to just try and check which one actually works. You can guess them in any order you like. So we're going to do synthetic division to see which one actually works. So I have 1x cubed, negative 7x squared, 13x, and the last number is negative 3. And we learned the synthetic division in the previous lesson. So I want to just check if 1 is actually a 0. So I'm going to try the 1. Bring down the first number, multiply, add. Multiply, add. Multiply, add. And when I add them up, I see that the sum is not a 0. So 1 did not work because I get a number here different than a 0. So 1 is not a 0. So option 1 is canceled. So 1 is not working here. So 1 didn't work. So we know that 1 is not a rational 0. So 1 is gone. Now we're going to try negative 1. Let's see if actually negative 1 would work. So we're going to try if negative 1 would work. So bring down the first number. 1 times negative 1 is negative 1. Add them up, negative 8. Multiply them, 8. Add them up, 21. Multiply them. And again, the sum is not a 0. It's negative 24. Even negative 1 did not work. So we know that negative 1 is also not a 0 for this question. So we have to move to the other options to see if they can actually work. So I'm going to delete these. So we're just repeating our synthetic division. Next, finally, I want to try if 3 is going to work. Bring down the 1. 1 times 3 is 3. add them up -4, multiply -12, add them up 1, 1 times 3 is 3, add them up 3. Really, finally, we got the number we have been looking for. So 3 gave us a remainder of 0 for synthetic division. So we know that, yes, 3 is a 0 for this question, which means 3 is a solution, okay? But if this is a third degree question, it needs to have 3 zeros. And the one that I got is just 1 0. So I definitely know that now 3 is a 0. But how am I going to find the other 2 zeros? Now we're going to go back to our synthetic division, and we learned how to write our answer after the synthetic division. If the question starts with a third degree, my answer starts with the second degree. So we're going to have 1x squared minus 4x plus 1. This is called the depressed polynomial. And we're going to set this to a 0. Now, this is a quadratic equation, and we learned how to solve quadratic equations in the very first lesson, section 1.4. We have the quadratic formula, which can always solve this equation. Quadratic formula was, first we need to find the delta, which is b squared minus 4ac. So it's -4 squared minus 4 times a is 1, c is 1. So that's a 16. 16 minus 4 is 12. So delta is 12. Now we're going to calculate the square root of delta, which is square root of 12. And that's 4 times 3. 4 can go outside as 2, and then the 3 stays here. Now, this is going to return 2 zeros to me, which is in the form of -b. So I need the opposite of this number, which is +4, plus and minus the radical delta all over 2a, and a is 1. So 2 times 1 is 2, which will give me, if I divide them by 2, okay. So in summary, this question here is going to have 3 zeros. One of the 0 is a rational 0, so it is like a whole number, so it's a rational 0, 3. And then the other solution is 2 plus radical 3, which is an irrational number. And then the last 0 is 2 minus radical 3, which is an irrational number. So this polynomial function has 1 rational 0, 2 irrational zeros. And we have to always perform quadratic formula or factoring after we guess one of the zeros by using the synthetic division. We have to use our depressed polynomial and use the quadratic formula or factoring to find the other 2 zeros. And this is how we handle these questions. We're going to have another one like this. But let's see if what I showed you is the smartest way to handle the next question. So it's the same question, find all the zeros, write the answer in exact form. So when I have a question that looks like this, which is a third degree question and there are 4 terms, before I showed you what I have done on the previous question, I always do factor by grouping to see if I can actually factor the problem and find the zeros. The reason I didn't even try factoring here, because I did the grouping, factoring by grouping in my head, and I see that these two have in common x squared, so they're going to give me x minus 7, and 13 and 3, they don't have anything in common. So I knew that grouping is not going to work here, even though it's a third degree function with 4 terms. But for this question, I can always do what I showed you on the previous question again, but I want to actually see if I can just factor it and find the rational zeros. So factor by grouping, these two, they have an x squared in common, parentheses, and I will get 13x minus 1. Let's check my work. If we multiply these two, they will give me a 13x cubed. X squared times 1 is just x squared minus. Now these two, they have a 5 in common. So 13x, because -5 and 13x is -65x, and I will need a minus 1 here, because -5 and -1, when I multiply them, they give me a +5. Now remember, factor by grouping means it's always a 2 steps work. Because now these two are matching, I'm going to write them only once, and I will put the x squared minus 5 together in a different parenthesis. Now, I'm almost done, and I don't have to do anything extra for this question. If I know that this factor goes down with me, and I know how to set it up to a 0 and so for x, but this one, I can factor it further. I can factor this as x plus radical 5 and x minus radical 5, because if you square the radical 5, you get 5. So this is like in the form of a squared minus b squared. And the factors for a squared minus b squared is always a plus b and a minus b. I have 3 factors, which will give me 3 zeros. All I have to do is take each factor, set it to a 0, solve for x. So I will take the 13x minus 1, set it to a 0, and let's just isolate the x here. So 13x is 1, divide each side by 13. So x is equal to 1 over 13 is one of the solution I need. Next, I have the x plus radical 5. I just have to set this to 0, subtract radical 5 from each side. So x equals negative radical 5 is the second solution. And then I know that this is just going to be opposite of what I got here. So I'm just going to go ahead and tell them that the last solution is x is equal to radical 5, positive radical 5. So this question has 3 zeros, 3 zeros. So on Alex's homework, we're going to give them all these zeros in list form. So you will tell them that one of the 0 is 1 over 13, comma, second 0 is negative radical 5, and the third 0 is positive radical 5. So order shouldn't be a big deal. Order is not important. So you can give them in any order you like. And that's how you do this question with factoring by grouping. Okay, next question here. We have again third degree polynomial function. We want to find the zeros here, and we're going to write the answers in exact form. So exact form means, for example, here on the previous question, radical 5 is an exact form. If I express it as a decimal, how calculators give me, it's not the exact form. So let me go back to the question. I'm trying to see if grouping will work like the other problem, but see, this one will give me x minus 5, but there is no way I can get x minus 5 here, so I know grouping is not going to work. So I'm going to go through the long way. So last number is 8. Factors of 8 is plus and minus 1, plus and minus 2, plus and minus 4, plus and minus 8. And the leading coefficient is 1 because we have only one x cubed. And then the factors are plus and minus 1. So when I create the list of the possible rational zeros, 1 divided by 1 is 1, 2 divided by 1 is 2, 4 divided by 1 is 4, and then 8 divided by 1 is 8. Okay? So I'm going to use one of these numbers to do the synthetic division and check if it's actually a 0 or not. So if we use 1, remember last section we used a remainder theorem. So if I plug in 1 in my head quickly, I see that that's going to be a negative 4, 8, and it looks like 1 is going to work. So we're going to check, let's check if x equals 1 is a 0 or not. So when I say check, when we do the synthetic division, we're going to see if the remainder is a 0. So I have 1x cubed, negative 5x squared, 12x, and the last number is negative 8. We want to check if 1 is going to give them a remainder of 0. Bring down the first number, multiply, add, multiply, add, multiply, add. Yes, here we go. I got the remainder of 0. So this is a confirmation that x equals 1 is a 0. So let's write the depressed polynomial, the polynomial we get here. If the question starts with cube, remember, so we're going to get 1x squared minus 4x plus 1a. This is what I got now. So 1x squared minus 4x plus 8. So we have to just solve this quadratic equation next. If you can solve it by factoring, so in this case, I feel like this question is not possible to factor because 8 is just really negative 2 times negative 4. When I multiply negative 2 and negative 4, it gives me a positive 8. But when I add them up, their sum is negative 6. But we have a negative 4 here. So although it looks like it's a polynomial that we can factor, but in fact, we still have to go through the quadratic formula. So We're going to find the delta first, which is b squared minus 4ac. So b is -4, so I will need -4 squared minus 4 times a is 1, c is 8. So that's a 16, that's a -32. No wonder. So the delta is a negative number, which gives me a 4i when I take the square root of the delta. So square root of delta is, delta is actually without the square root sign. So let's just make this. And then if we want to just find the square root of delta, we just take the square root of this number, which is 4i. Okay. Now, I'm going to find the two zeros. Again, I'm using a quadratic formula. You should be already very comfortable with this because this is what we have been doing since the beginning of the semester. So I need negative b, which is just 4, plus and minus 4i over 2, which will give me 2 plus and minus 2i. So these are the other two irrational zeros, or in fact, these are complex zeros. So even though this question, it's a third degree question, it has 3 zeros. One zero is 1, and then we call this rational zero. The other zero is 2 plus 2i, and then the third zero is 2 minus 2i. So this polynomial function here, it has 3 zeros. And then this is how we do these questions for this one. Okay, finally, we're changing our objective. So the third objective is, I do remember that we did all of these questions, like one example from each with the previous section too, but this section we just do more examples. So how do we construct a polynomial if the zeros are given? So the question is right now, the objective is now writing polynomial function if the zeros are given. If the zeros are given. Okay, so write a polynomial function that satisfies the given condition. Degree 3 polynomial with integer coefficients with zeros 2i and 9 over 7. Okay, so we have the zeros this time, and then we're going to find the polynomial function. Okay, one of the zero is given as 2i, the other zero is given as 9 over 7. Now, if you have a third degree polynomial, you need to have 3 zeros given to you. But how we have only 2 zeros here and we still have to find a polynomial? Because the complex solutions, they come in pairs. If 2i is given as a solution, they don't have to tell you. You will automatically know that negative 2i is also another zero. So because you have to know this fact on your own, now you know that degree 3 polynomial, it has 3 zeros, a positive 2i, a negative 2i, and 9 over 7. These are the 3 zeros, and we're going to find the polynomial. Now, if 2i is a 0, the factor associated with this is x minus 2i. So when you take it, set it to 0, x equals 2i is the 0. If negative 2i is a 0, the factor associated with this one is x plus 2i. Again, remember, these always the same, just the sign of difference. So when you FOIL them, you're going to get a nice function where i's disappear. And this is a tricky one. This is how we do it. We write the denominator first. So we need 7x. And then we write the opposite of this number, which is minus 9. So we need a 7x minus 9, because when you take the 7x minus 9, set it to 0 and solve for x, it gives you a 9 over 7. So in order to answer this question, first, we're going to FOIL x minus 2i by x plus 2i. Once we have the answer to that, we're going to also multiply them by 7x minus 9 to find the f of x in this given question. This is how we do it. To find the f of x, we just have to multiply these three factors. So let's multiply x minus 2i and x plus 2i first. X times x is x squared. X times 2i is 2ix. These two will give me a negative 2ix. And then these two will give me a negative 4i squared, which will give me a plus 4. And then once I simplify this answer, I'm going to multiply them also by 7x minus 9. So don't forget here, these two will always disappear. So you're gonna end up with x squared plus 4 that you're gonna just multiply by 7x minus 9. So that makes 7x cubed, and then this makes negative 9x squared. This one makes 34 times 7 is 28x, and then these two will give me a negative 36. And this is the expected answer for this question. If the zeros are given, this is how you construct a polynomial function. Okay, next question is pretty much the same. Write a polynomial function that satisfies the given condition. Express the polynomial with the lowest leading possible positive integer coefficient. Polynomial of lowest degree with lowest possible integer coefficient and with zeros, 9 minus 7i and 0. And multiplicity is 5. So let's see. 9 minus 7i is given as a 0. And we have to automatically know that 9 plus 7i must be also a 0, because again, these two comes always in pairs. Even if they don't tell us, we have two zeros here. And then the other 0 is just 0. So we know that the factor associated with that one is just x, because x minus 0, right? And then this one has a multiplicity of 5. So that means we're just going to have to multiply these two once we FOIL them. We're going to also have to multiply them by x to the 5th. Okay, so let's find the factor associated with this. So the factor will be x minus 9 plus 7i. So when I set this to 0, it gives me this. And then this one is x minus 9 minus 7i. And then once the FOILing is done, we're going to also multiply them by x to the 5th. So this one is x squared negative 9x. And then this one is negative 7ix. I'm going to move to the negative 9 now. Negative 9 times negative 9 is positive 81. Negative 9 times this one is plus 63i. And then plus 7ix. And then negative 63i. And then negative 49i squared. So let's see. This one and this one cancels out. This one and this one cancels out. Now remember, I told you that every time we see an I squared, we have to replace it with negative 1. So the I squared has to be replaced by negative 1. So here, negative 49 times negative 1 will get me a plus 49. So these two, I don't need this complicated thing, but I just need a plus 49 there. So let's simplify. We got an x squared minus negative 9x and negative 9x. When I combine them, that's a total of 18x. And then 81 and 49. When I add these two up, 1 plus 9 is 10, 8 plus 4 is 12, so that's 130. That's what we get when we FOIL that. So x squared minus 18x plus 130, but we just have to multiply them by x to the 5th also to find the polynomial we need, which will give me x to the 7th minus 18x to the 6th plus 130 x to the 5th, and this will be the expected answer for a question which looks like this. I have one last question left to cover on this section. I can only find it. Okay. Okay, so the question is now, find the zeros and their multiplicities, considering the Descartes. Okay, so we don't have to really follow a lot of details here, but this is a third degree polynomial function. So we're gonna again repeat everything we have learned with the previous questions, and we're gonna find the zeros of this function if it is 8x cubed minus 18x squared plus x minus 6, x plus 6. So the last number is 6. factors are plus and minus 1, plus and minus 2, plus and minus 3, and plus and minus 6. Leading coefficient is 8, so the factors are plus and minus 1, plus and minus 2, plus and minus 4, and plus and minus 8. So when I want to find the list of the possible zeros, 1 divided by 1 is 1, 1 divided by 2 is 1/2, 1 over 4, 1 over 8, 2 over 1 is just 2, 2 divided by 2 is 1, which is right here, 2 out of 4 is 1/2, right here, 2 out of 8 is 1/4, it is right here. 3 divided by 1 is just 3, comma, 3 divided by 2 is just 3 over 2, and then 3 over 4 is just 3 over 4, and 3 out of 8. 6 divided by 1 is 6. 6 divided by 2 is 3, but we already put it there. 6 divided by 4 is 3 over 2. It's right here. 6 out of 8 is 3/4, and it's right here. Okay, we have a lot of options to try. So I don't know actually which one is going to work. So we're going to go ahead and take a shot. We're going to go ahead and try 8. Why did I choose 8? I don't know. There are a lot of even numbers here. So I wanted to just give a try for 8. So let's start with our synthetic division. 8x cubed, negative 18x squared, 1x, and 6. And we want to check if 2 is going to work with these numbers. Bring down the 8, multiply, add. Multiply, add. Multiply, add. And yes, I got the remainder of 0, which is very nice. That means 2 must be a 0 for this question. So we know that definitely 2 is one of the zeros that we're looking for. Now let's see, now we have a second degree polynomial function, which is 8x squared minus 2x minus 3 set to a 0. Again, I can try to factor this. So I'm going to go ahead and factor because I like factoring, but if you're struggling with factoring, you probably don't know how to do this. This didn't work. So this is the try and error method. If you learned other techniques in your previous math class, you can also use them. I want to now separate them as 4x times 2x because when I multiply them, that's 8x squared. And there's a 3 that I need to break down here. So I want to do 3 and 1 here, and that's a negative 3. So one of them has to be negative, the other one has to be positive. So when I multiply them, I get negative 3. I still don't know if these are the correct factors. So when I multiply these two, they give me a 4x. When I multiply these two, they give me a negative 6x. And when I combine them, that's a negative 2x, which is in the middle. That means these are the factors I'm looking here. So since I confirmed that I was able to break down the numbers correctly, that means one of the factors I'm looking for is 4x minus 3. The other factor I'm looking for is 2x plus 1. I didn't have to go through the quadratic formula here, but if you're struggling with factoring, you are very welcome to use quadratic formula. Take this one, set it to a 0, and then solve for x. X is 3 over 4. Take the 2x plus 1, set it to 0, and solve for x. So this question has 3 zeros, 2, negative 1/2, and 3/4. And you can set them in any order you like. So this is how we're going to use the synthetic division, listing the possible rational zeros, factoring quadratic formula all together to master section 3.4, which is about finding the zeros of polynomial functions. Good luck with the homework.